Our learning targets for today are I can explain the story told by the graph of a function, and I can draw the graph of a function that represents a real-world situation. Graphs of functions can give us information quantitatively, which means a graph that gives specific numeric value. This happens when the graph has labels and scales on the axes. Looking at the graph pictured, we notice that the dependent variable represents the temperature measured by degrees Fahrenheit. The independent variable represents the time measured by hours beginning at 12 noon. In this case, the labels have given us very specific information. For example, at 4 o'clock in the afternoon, the temperature is 57 degrees Fahrenheit, or that the high temperature of 59 degrees Fahrenheit occurred a little before 6 o'clock in the evening. Sometimes it's more difficult to be specific numerically on a graph, but we can still gain information from the labels and the overall general shape of the graph. On this graph, the dependent variable is the amount of garbage measured by thousands of tons. The independent variable is time given by a specific year. Notice that from 1991 through 1994, the amount of garbage increased. But from 1994 to 1996, the amount of garbage decreased. We could continue to describe the different periods of time and what was happening, whether it's an increase, a decrease, or in some cases, little or no change as we go from year to year. Although we cannot give specific amounts of garbage, we could use the scales on the dependent variable to give an estimate. Have you ever heard the saying, every picture tells a story? Since every graph is a picture, it tells a story by its labels, scales, shape, and other characteristics. When a graph is made to model the context of a real-life situation, sometimes there may be choices when choosing the dependent variable. Pause the video to view the time-elapsed photos above, and then look at the two graphs drawn to picture the story of the photos, and then explain what Diego and Lynn were thinking when they drew their graph. Notice that Diego and Lynn have each chosen a different dependent variable. Diego's graph shows the distance that the dog runs compared to the independent variable time. Lynn's graph shows the distance between the dog and the camera compared to the passing of time. In Diego's graph, the dog stays in the same place for a little while and then begins running. The same thing happens in Lynn's graph. The dog stays in the same place for a little while and then begins running, but running towards the camera. Both graphs are correct in representing what is happening in the photos, but it depends on the explanation or the context to explain what is happening. Pause the video for a moment and take time to read this list of things to think about when looking at a graph. The above graphs show the volume of water over a period of time. Pause the video for a moment. Can you explain what is happening in each graph? Pause the video one more time and check your thinking. Can you explain the story told by the graph of a function? Can you draw the graph of a function that represents a real-world situation? Use these notes to help you explain or draw graphs as you continue your math work today.